Hello, today we're going to talk about elementary reactions. So elementary reactions are single-step reactions. That means that it occurs all at once without taking multiple steps. But elementary reactions are useful for us because we can write a rate law based off of just that balanced chemical reaction as long as we know it's a single step. So let's look at a couple examples. If I have like 2NO forming N2O2, all right, that means two NO molecules have to collide with each other and they will combine to form N2O2. Now, they'd have to give you some information, like they'd say it's an elementary reaction, or they'd say it happens in a single step, and that's how you know like it's an elementary reaction. From there, if you know that it's an elementary reaction, then you can write the rate law. And so it would be rate equals K. And because we know it's a single step, we know those NO2 molecules have to collide. There's two of them that are colliding. So the coefficient becomes an exponent. And you only include the reactants, never the products. And again, you can only do this if it's an elementary reaction. Let's try another one. If I have N2O2 N2O2 reacting with O2 to form 2NO2, like this. That means the NO2 molecule and the O2 molecule have to collide, and then they will form two NO2 molecules. So your rate law for this would be K N2O2 times O2, just like that. Now again, I'd have to tell you it's a single step or an elementary reaction in order to be able to do that. If they don't give you that information, then you cannot use the balanced chemical reaction to find the rate law. You would have to use experimental data or other information to write the rate law. Okay, so there's a concept here called molecularity. So that has to do with the number of molecules that have to collide in order for the reaction to happen. So you have unimolecular reactions where it's really just one molecule, unimolecular, there we go, one molecule itself. So maybe that molecule is decomposing or changing form in some way. So it doesn't have to collide with anything else, unimolecular. You can have bimolecular, where you have two molecules colliding with each other. And then anything bigger than that is going to be extremely unlikely. So you'd have, trimolecular or bigger is very unlikely. And this comes up sometimes on free response. So they'll give you an example like 2NO plus O2 yields 2NO2. So they'll say, is this reaction likely to be an elementary reaction? Well, you'd count the number of reactants. There's 1, 2, 3 reactants total. So in order for this to happen in a single step, all three of those things would have to collide at the same exact time in the same perfect orientation for it to work. And that's extremely unlikely. So you'd say, no, this reaction is not likely to be in a single step because it would have to be trimolecular. It's very unlikely. But if it's unimolecular or bimolecular, it is definitely a possibility that it is a single step. It's not always a single step, but it's possible that it's a single step. So now let's just briefly look at those examples that I've already kind of given you. If we look at that first elementary reaction that we had was 2NO yields N2O2, and we know this is bimolecular because there's two NO molecules. The other elementary reaction I gave you was the N2O2, reacting with O2 to form 2NO2. Okay, so you can actually put these steps together to make an overall reaction. So each of these are elementary steps. If you add them together, you can form an overall reaction. So when you're doing this, you would put all of the reactants on one side and all of the products on the other side. And then anything that is the same on both sides cancels out. So the N2O2 cancels out, and you're left with your overall reaction, which is here. Oops, NO2. So you can see that you have two elementary steps. Both of those are bimolecular. And if you put them together, they create this reaction with 3 molecules reacting. So it's still possible to do this reaction. It's just not going to happen in a single step. You'll have to have multiple steps added together. Now the NO2 cancels out. Because it was a product in the first step and a reactant in the second step, we call that an intermediate. It is kind of between steps, so it's an intermediate. We're going to get more in depth with intermediates in a later section, but for now that should be enough to get you guys going. Okay, so here's another example. What is the overall reaction and what is the rate law for elementary step 1? So to find the overall reaction, we're going to put all of the reactants on one side. And all of the products on the other side. Then anything that's the same on both sides will cancel out. Now you can do that part in your head if you want, but I'm just showing you so you can see what I'm doing. So there's my overall reaction. Now this overall reaction is bimolecular, but because they told us, what we call the mechanism, they told us that it happened in 2 steps, that's fine. So we know that H2I2 is the intermediate because it was a product in the first step and then the reactant in the second step. And then for the second part here, what is the rate law for step 1? We just need to use the reactants in step 1. So you would write rate equals K. You always start rate equals K. And then brackets HI. And there's 2 of those, so it's squared. And that's it.